Okay, let's me start with the chapter 8. Anyway, it's gonna be talk about the non-permanent connections. This type of non-permanent connection is gonna be the trade fast in a way. In the case of being able to disassemble the joint connections of a workpiece frequently, this is gonna be the non-permanent connections like trade fastness such as screw nuts that was said in here. Screw nut bolts are extensively used for fastening workpiece or machine parts together. At what frequency? Then what we take machine parts out of each other frequently. Being able to disassembly, what is said in here. The joint connectors of the workpiece or the machine company is the most advantage of the trade fastener over the other types of connectors such as rivet or welding connections in a way. So let's see the trade form and terminologies and the standards, things like that. So typically, that what we gonna have a trade gonna look like that in figure A and B respectively. In figure A, it's gonna be a standard single trade right hand. It's gonna wrap over a cylinder, things like that. Okay, it's gonna wrap in the right manner, right hand all the way, and then on the figure B, we're gonna have a left hand. It's gonna seem like it's gonna wrap things up in the right hand position, whatever. One thing is gonna be single is gonna be the pitch. It's gonna be one trade to another trade, things like that. The pitch to pitch, things like that. And then the lead L is there. So it's mean L is equal to P. So it shows to be the single one trades all the way. And then in here, L is equal to 2P respectively. So therefore, the things that going to show us up there is going to be the things that what we have got there is going to be the things that what we left over here there. So therefore, that what we're going to have a typical type of formulation is going to L is going to be the leads, and then equal to N sub W times P anyway. What does it mean by the leads anyway? The lead is going to be defined as we turn around the cylindrical things like one round seems like the pitch or the trade gonna transform or have a positions of a movement in one rotation, things like that, or one L, things like that. Or we might say that if we just turn around the trade one revolution, the trade gonna move forward or backward one L. That's what we call the definition of the L, the lead anyway. And the pitch is gonna be the distance apart from one trade to another trade anyway. So therefore, typically the things is gonna show like that. Another thing is gonna be the lambda. Lambda is gonna the lead angle. It show you up there the vertical axis there, and then the inclination of the trade incline with the with the vertical line, things like that. We're gonna call the lead angle. And then tan lambda is gonna be equal to L equals over pi d. Pi d is gonna be we're gonna wrap things up in one revolution, things like that. It's gonna be pi d anyway. D is gonna be the mean diameters of the pitch diameters anyway. Okay, so D is gonna be the mean diameter that I want to show you up there. Okay, so therefore this is going to be the things that what we're going to be definitions all over. And then in figure 8.2, it's going to be if we cut off, this is going to be the axis of symmetry anyway. Half of it is going to show up there. And we're going to have the capital and the small is going to be show some of you up there. Where is the D and D is going to represent there is going to be the things that what we said in here is going to be the D capital is D1 and D2 are the internal trait, and the D small and D1 and D2 are the external trait respectively. Is mean the internal trait is mean the nut, right? We're gonna have the trait inside, and D and D1 and D2 is gonna external trait. That's what we the external trait respectively. That's gonna call it the bolts and nuts respectively. So therefore, if we got the bolts, we're gonna have the small there, and then we have the capital D. It's gonna have the internal trait. It's gonna call it nuts respectively. So therefore we're gonna have major diameter. You're gonna have a look at it. The major diameter is gonna have the capital D there. So we're gonna have the capital D is gonna be the largest diameter there. So we're gonna have the largest diameter. It's gonna major nominal diameter. I would like you guys to underline the terms of nominal. Nominal is mean you can be able to take a measurement on that. So therefore, if you take a measurement, it's going to be standards all the way. You can manipulate the size of the trait. So there's going to be nominal diameter is going to be the major diameter, the largest diameters anyway. And then D1 and the capital D1 and the small D1 is the smallest diameter is a trait. It's going to show up there the root diameter, whatever, and then D2 is gonna be the major or the minor diameter respectively. Two, the D2 is gonna be the mean, things like that. It can be between things like that. Okay, and then the H is gonna be the 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 the, the triangle, get a triangle, height, things like that. Okay, and then the metric trait system standards is gonna have M. It's gonna be 12 times 1.75. 12 is stand for the major diameter, and the last after the X, things like that, is gonna be the terms of the pitch anyway. Okay, and the left hand we're gonna have the thing that show you LH respectively. So therefore, in table 8.1 and 8.2, you're going to you show the coarse pitch and the fine pitch respectively. Coarse pitch is mean not so many thread, right? And fine is going to be really not so many teeth, things like that. Okay. So therefore, nominal major diameter is the first choice there. Is going to be this is going to be the things that was most available. Second choice is going to be difficult to find, things like that. Okay, the pitch, D2, D1, and D1 and D1, the small D1 and the capital D1 respectively. A sub S tensile stress area. Okay, I'm going to show you up there. A sub S is mean I jump it over it. Okay. I would like to show you up here. A sub S is gonna be show you in the figure up here. Okay, 8.9. A sub S can be able to determine from pi over 4 d2 plus d1 over 2 to the power of 2. Okay, d1 and d2 show you up there. So already it's gonna be the major diameter. Okay, because it's gonna be some kind of like cylindrical things like that. The trade form is going to be look like that. It's going to be major, nominal, major diameter, and the minor diameter respectively. So therefore, we're going to be a shaded area or some kind of straight area or whatever. Get it to me look like that. So therefore, this is the A sub S. Can be determined on that. We can make a calculation. So therefore, we can be able to find it. Okay, based on the standard form, we can have it here. So we got the A sub S in the table 8.1 for the cost pitch, right? So the cost pitch, we don't have to manipulate the pitch, okay? The pitch is gonna be not so many traits in a way, okay? So therefore the cost pitch there, okay? And then the fine pitch, we're gonna show you of the pitch, okay? 8 times by 1, things like that. The A sub S is gonna show you up there, and then the fine pitch is gonna be all over there. Gonna show you up to the 180 respectively. Okay, and then now the trade form, the trade fatten type. Okay, we have number one for the bolts and nuts. Okay, in figure 8.3, the bolt is going to look like that, and we have a nut. Okay, we have a workpiece together, we have a bolt due through, and then we have a nut to fix it up on the bottom, things like that. Okay, and then we have a screw. Okay, screw. Okay, we have a thread on the workpiece at the bottom there, and then we screw it over. Okay, and then the stud. Okay, we have some kind of like the stud bolts. Okay, we have thread. Okay, fastened in the brake piece down under. Okay, and the stud we have a nut to fix up in the upper parts, and we have a washer on the top, things like that. and then trace slot and knot. Okay, we have trace slot all the way, put it through, and we have washer on the top and bottom, and then we have a knot to fix it over at the top and bottom respectively. And then on number 5, machine screw. Okay, this one is going to be a screw for a machine, things like that. Okay, we have trades all over. These are hexagonal, square head, round head, flat head, things like that, overhead, feed stir, things like that. Okay, this is the things that what we have a special form. This is going to be the things that what we use frequently. And then set screw. This kind of going to be careful for the set screw. Set screw is going to be the things that what we use it to sit down, okay, in a proper manners for the workpiece there. Okay, we're going to have a table there to sit is on the workpiece to make tight, okay. So therefore, this one is going to be offered to sit down on the workpiece, things like that, okay, in a proper manners, things like that. When it's common set screw, when they have a different types of the set screw, whatever. Okay, and then for the tensile stage area, I talked it over already. So therefore, we can make a calculation either, or you be able to just use the table of 8.1, 8.2 respectively. Another one, it's gonna be based on the ISO. Okay, these standards of ISO anyway. We can be able to just specify the class or the property class of the bolts and nuts, okay, based on the 8.3 and 8.4 respectively. I tell you what, okay, this is a class, okay, that been specified by ISO anyway. It's been the qualities of the ISO anyway, kind of classified of 3.6, 4.6, 4.8, 5.6, 5.8, things like that, okay. In Thailand, okay, then what we've got is going to be up to 3.6, up to 5.8 only, okay, because as well, you see the properties of the material or the steel, things like that, is not quite high anyway. So therefore, if you would like to find a higher, okay, steel, things like that, 6.8 up to 12.9, things like that, okay, we got to make an order, maybe probably maybe from Japan, things like that, closer country, things like that, okay. I would like to go for the property class, things like that, so highlight it please. Typically in Thailand, it's going to be less over 4.6 and 4.8 only. So I would like to show you guys on this kind of table. Okay, the table 8.1 and 8.2. Okay, I would like to show you up there. Sorry, hold on. Oops, hold on. 8.3. Okay, so it's here. It's gonna be very important here. It's 8.3 show you the minimum proof stress of the cross pitch. Okay, the cross pitch, right? Okay, it mean this is gonna be the minimum proof stress. It mean the stress, okay, or the proof force. The things that show you up here is gonna be the proof force. It mean that is the things that what the owner of the manufacturer who make productions of the bolts and nuts, okay, whatever, they guarantee that okay their bolts and nuts can be able to provide a minimum force of this, okay. So therefore we got to design and use this kind of value for the minimum value anyway. For instance, if I just use the major nominal diameter of M5, things like that, okay, with the property class of 4.8, things like that, I just guarantee, okay, the owner of the manufacturer guarantee that, okay, they can be able to use their boats with the minimum of force of 4,400, things like that, okay. So we can design on the boat to use the minimum force of this, but of course they can use, I mean, much more than that, whatever, but they guarantee that their boat can be able to withstand the amount of force of 400, 4,400, things like that, okay. So this is the thing that what we're gonna use is gas guarantee force, things like that. Okay, 8.4 is gonna be the coarse pitch, right? And then 8.4 is gonna be the fine pitch respectively. Okay, the fine pitch of course is gonna be better. Okay, it's for example like 16, M16, things like that. Minimum force of the 4.8 class is going to be 5,000, 51,800, things like that, right? So this is the things that will show you on the proof force, things like that. But be careful, okay? The class is going to be important, okay? In Thailand, okay, we have a public class of this kind of thing. But of course, if you would like to obtain just more public class, things like that, okay, we got to just make sure that our class of the votes that what we make a selection is going to be on the things that what we just make sure on that, okay? But typically, we're going to have some kind of certified of the vote that what we're going to buy on it anyway, okay? All right, so things like that, okay. And then, okay, I would like to go for, okay, another section. It's going to be in table 8.5, okay. I stop for a while for this, okay.